4-1, prime factorization. A prime number is a whole number greater than 1 that has exactly 2 factors, 1 in itself. A composite number is a whole number greater than 1 that has more than 2 factors. 0 and 1 are neither prime nor composite. So here are a list of some prime numbers. The factors for these numbers would be 1 and 2 would be the factors for 2. Factors for 3 would be 1 and 3. Factors for 5 would be 1 and 5. Factors for 7 would be 1 and 7. These are prime numbers because they only have the number 1 and themselves that give them the ending number. Now, composite numbers include 1 and itself, but they also include another number. So for 4, it would include 2 because 2 times 2 is 4. For 6, you have 1, 6, 3, and 2. For 8, it would be 1, 8, 2, and 4. For 9, 1, 9, and 3. And for 10, 1, 5, and 2. The factors are the numbers that you multiply together to get the composite number. Pause the video to determine if the numbers are prime or composite. 17 would be an example of a prime number because you can only multiply 17 by 1 in itself. 12 is an example of a composite number because there are multiple numbers that multiply together to give you 12. 1, 2, 3, 4, 6, and 12 are all the factors of 12. 11 is a prime number because you can only multiply 1 by 11 to get 11. Every composite number can be written as a product of prime numbers, and that is called prime factorization. So let's look at some ways that we can do this, and we can visualize this or demonstrate this using what we call a factor tree. So for 60, we can multiply 6 times 10. So those would be 2 factors of 60. Well, amongst those, you could also do something to those numbers. So for 6, you could multiply by 2 times 3, and then for 10, you could do 5 times 2. So we would be able to bring all of these down and say 2 times 3 times 5 times 2 would give us 60. You can also break it apart differently, and you could break it apart as 12 times 5. So for 12, you could do 4 times 3, but then 4 breaks apart into 2 times 2, 3, and then you bring down the 5. So the factors are the same, they're just in a different order. So the prime factorization for 60 would be 2 times 2 times 3 times 5, or 2 squared times 3 times 5. So when we're finding prime factorization, we can do it 2 ways. We can do the factor tree, which we previously saw. So for 24, you could break it into 12 times 2, and then you could break 12 into 4 times 3, and then this would be broken into 2 times 2, bring down the 3, bring down the other 2, so this could be 2 to the 3rd times 3, or you can divide it. So we can say 24 divided by 2 gives me 12. 12 divided by 2 gives me 6. 6 divided by 2 gives me 3. So I still have the same prime factorization, it's just a little bit of a different way to look at it. when we are doing factorization, we can also factor algebraic expressions. So for this example, you could pull this apart and say 6 times AB. Well, 6 can be broken apart into 2 times 3. AB is A times B. So the prime factorization for 6AB is 2 times 3 times A times B. Pause the video to complete the lesson review. Make sure you show me the lesson review for verification of this video.